Hello, I welcome you all. The problem reads, disk A has a mass of 250 grams and is sliding on a smooth horizontal surface with an initial velocity 2 meters per second. It makes a direct collision with disk B, which has a mass of 175 grams and is originally at rest. If both disks are of the same size and the collision is perfectly elastic, determine the velocity of each disk just after collision. Show that the kinetic energy of the disks before and after collision is the same. So this problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. So here we are dealing with impact. So what is impact? Impact occurs when two bodies collide with each other over a very short period of time, causing relatively large impulsive forces exerted on or between the bodies. An example of impulsive or impact loading is striking of a hammer on a nail, or striking of the golf club on a golf ball. Okay, so what is happening here? So we have a disc here, okay, that slides on the smooth surface. It means no friction here, no friction, smooth horizontal surface. So this means no friction. Okay, so we can think of this is a disc. This is disc A. Okay, then let's think of this as a surface. So let's say it is sliding. Let's say it's going in this direction like so. Okay, right, and it is moving at an initial velocity of, we call this VA1 equal to 2 meters per second. Right, what else? Of course, this mass also here we've been told this is equal to 0.25 kgs. Let's say we do have another disk, disk B, okay, and this one we've been told it is at rest, or there is no need of showing this, so we can just say our VB1 is just equal to 0 meters per second, and our MB is just equal to 175 grams. Convert it to kgs to just 0.17 kgs. So what is the question? The question is to determine the velocity of each disk after collision. So because we are going to consider this as a system of particles, therefore we expect momentum itself to be conserved. So because momentum is going to be conserved, we can use the principle, you can use the principle of the conservation of momentum, where we have MA VA1, okay, plus MB VB1 is equal to MA VA2 plus MB VB2, right? So this part here we do have a 0.25, okay, and then by VA we say this is just 2, then plus MB is just 0.175, okay, VB is 0, and then this is just going to be equal to MA is again 0.25, VA2 it is just VA2, we don't know it. This is what we intend to find, right? So we'll just write it as VA2, and then we'll say plus MB is 0.175 VB2, okay. All right, so this is 0.25 VA2. All right, so if we were to write this just becomes a 0.50, which is just going to be equal to 0.25 VA2 plus 0.175 VB2. So we do have one equation. So we've been told that this is perfectly elastic. Therefore, the coefficient of restitution itself E, okay, because here we know that, so we know that given that VA1 is greater than VB1, therefore our E is just going to be equal to, our E is equal to VB2 minus, and we also know that VB2 here, all right, so VB2 minus VB2 minus VA2, then divided by VA1 minus VB1, okay. So with this in mind, we know that since our E is just equal to 1, our E is equal to 1, so it will just be 1 equal to VB2. VB2, we know it just as VB2 minus VA2 divided by VA1, which is just a 2. So we know here that our VA1 is 2 and our VB1 is 0. so minus 0. So this just becomes 2 is equal to VB2 minus VA2. So this is another set. So if this was equation 1, this becomes equation 2. So we need to solve the two equations simultaneously. Again, there are a number of techniques that we can use. So let me say I write this just becomes VB2 equals to 2 plus VA2, and then feeding it in there, it just becomes 0.5. This is equal to, we feed it down here, so feeding it into here, this just becomes 0.5 is equal to 0.25 VA2 plus 0.175. Then we feed this as 2 plus VA2. So if we are to sort out this, our VA2 is just going to be equal to, let's sort out this one, so 0.25 plus 0.175, so there we go, and then we say 0.5 minus 0.175 times 2, then divided by answer. Okay, so this gives me a 0.3529 meters per second. So this was our reference, this is our reference, so this, it means it's going in this direction like so. So let's check it at it again. 0.25 plus 0.175 okay, then we have 0.5 minus 0.175 by 2 divided by answer 3529. Right, therefore our VB2 is just going to be equal to that one plus a 2, so this just gives us a 2.3529, and it is also going in this direction. Okay, let's work on the second part, which is to show that the kinetic energy of the disk before and after the collision is the same. Alright, so we know that the total work from 1 to 2 is just equal to the difference in the kinetic energy, right? And then this is going to be equal to 0 when E is equal to 1. Alright, so let's work it out. So we do have half mv2 squared minus half m v1 squared. So we do have half there. Let's work out. Let's start with the second state. So we do have 0.25. Okay, what is the velocity for air? It is 0.25 2.3529 squared, right, plus what else in the second state is half for B 0.175 by 2.3529. okay, then minus half so minus half half 0.25 2 just a 2, right, a 2 squared plus half 0.175 by a 0. okay, therefore the total work, if we computed this, okay, this is going to be equal to, let's work it out, so 0.5 by 0.25 times 0.3529 squared, 29 squared, plus 0.5 by 0.175 by 2.39, 2.3529 square. okay, then minus 0.5 times 0.25 times 2 squared, so this gives us a minus 0.0000 1 2 3 2 1 2 3 4 5. okay, like so, something like so, which is just approximately equal to 0. okay, so we've proven that this is the power negative, right, 1 2 3 4 5. all right, so we have proven that, so this is proven. okay, so this is proven that this is equal to 0, therefore it means that the kinetic energy of the disk before and after the collision is the same. okay, so I can say here proven. all right, I think this is about it. We have calculated the velocities for the disks. We've calculated also the energies, the kinetic energy before and after the collision. So I hope this particular video was helpful. And if it was, give me your thumbs up, like my video, and continue subscribing to my channel.